In this challenge review, we're going to look at how to create the player jumping. I've decided I'm going to show you both ways in a more recommended way. There's an advanced way to do this using a return type function, and then there's also a way to do this using a variable. So I'm going to go ahead and show you how we could do both. The first thing we need to do is we need a variable for our jump force. So I'm going to say here, private float, and we'll call this jump force. We'll go ahead and set that to about 5. If I ever want to extend this and I want to change this in the inspector, one of the things I can do is simply just right above it, type serialized field, and that's going to display it in the inspector so that I can modify this value. So we created our variable for jump force. We also need a variable to know if our player is grounded. That logic doesn't exist. We have to create the ability for him to be grounded. So here we're going to say private bool underscore grounded. And we're going to set it by default to false because we can assume right now looking at our player that maybe his starting position is in midair and he's just going to fall down. So we want to set it to false. We're going to let the raycasting be responsible for turning that true. Now that we have our private bool grounded equals false, let's go ahead and start filling in our pseudocode for how we actually jump. So if we hit the space key and our grounded bool state is true, so if space key, so we do input dot get key down, and we're looking for key code dot space. So if we hit the space key and our grounded state equals true, that means that we can jump. So here we're going to say jump. So to jump, we need to grab our current velocity, which is our rigid dot velocity, and we're going to set it to a new velocity. And we're modifying now the y. So here we're going to say a new velocity, which is a vector 2. And for the x, we don't want to set it to 0 or anything like that. We want it to be whatever the current velocity is. So for instance, this will allow me to be able to run and jump, not just jump straight up. So to do that, we're going to say underscore rigid dot velocity dot x. And for the y, we want to use our jump force. We can go ahead and save this and actually test it out. Let's go ahead and clean up some of our code here. So right now, our logic is we can move, but if we hit the space key and grounded is true, then rigidBody.velocity is going to add jump force. Now right now, grounded is false. I'm going to add a serialized field attribute above this so that we can modify that bool in the inspector for testing. Go ahead and let Unity compile. Stop running your game. When it's finished, we'll run it again. And if we select our player, you'll see here that we have our property of jump force and our property of grounded. So here, if I hit space, nothing's happening. But if I select grounded is true, you'll see here that I jump. And because grounded never goes false when I'm in the air, I can infinitely hit space to go up. But what's important here is we have working logic for our jump. I can also move around and jump. And you'll see here, because we keep our current x and y velocity, that we can jump in those directions. So let's go ahead and check out what we can do now about making it so that we can't spam the jumping. Open up our script. And in here, we need to now use raycasting to make sure that our grounded is only true when we're actually on the ground, right? And grounded goes false once we jump. So to easily fix this, we can simply add right here where we modify the velocity, we're going to go ahead and say underscore grounded equals false. But now what happens if we just do this? Right now, we're going to be able to jump one time and one time only. And the reason for that is because although this logic works, we don't have anything telling it that, hey, you're back on the ground and you can jump again. So right now, you'll see here on the player that our grounded is set to false. If I set it to true, I'm going to jump. It's no longer true, but it was never set back to true. So how do I jump again? And that's where raycasting is going to come in. So let's open up our script here. And we are going to cast a 2D raycast. So here we're going to raycast to the ground. So to do this, we're going to basically say physics 2D. Physics 2D raycast, I believe. Raycast hit 2D is what it is. Here we go. So raycast hit 2D. This is information returned about an object detected by a raycast in 2D. We're going to call it hit info. and we're going to cast the ray. So we're going to say hitinfo equals physics2d dot raycast. And from here we can use our tooltip. So we have 7 options. Basically we can say a vector2 origin, which is going to be our player's position. So we're going to say transform.position. Our direction, which is going to be down, so vector3.down. And then here you can say the distance. So how far do we want this raycast to travel? So we're going to go ahead and use that one, 2 of 7. So the origin is our transform.position. The direction is going to be vector2.down. And our distance, let's just say 1 unit. Let's save this. And what we want to do now is check if hitinfo is not null. That means that our raycast hit something. So here, if our raycast actually hits something, we can say if hitinfo.collider is not equal to null, meaning that it actually hit something, we're going to go ahead and say grounded equals true. Go ahead and clean up our pseudocode here. Let's go ahead and save this. In every frame, it's going to now cast a raycast and detect our collisions. Now, there is a way that we can actually view this raycast. A raycast is just an invisible line that is going to be casted in Unity. If we wanted to see it, there are programs and debug draws that we can actually use, and we're going to look at how to add one of those. So let's go ahead and run this. And you'll see here that currently our player is set to grounded, which is true. Now if I jump, you'll see here I can now jump. Now I'm jumping infinitely, which tells me that it's possible that our collider is getting hit by our own raycast. Now that could be the case, so I want to actually know what is it that our raycast is hitting. So to debug this, we're going to say if hitinfo.collider is not equal to null, that means we hit something. What are we hitting? So I want to say debug.log. We're going to say hit, and we're going to append whatever we hit. So hitinfo.collider.name, and that's going to return the name of the object we're hitting. So let's see if it returns player. Go ahead and let Unity compile. And let's jump. So right now, actually, if we look in our console here, you'll see here that it's infinitely hitting our player. So we need to actually tell it to ignore our player. Now, before we even do that, it might be useful to be able to see this ray. So let's open up our script again, and let's add a debug to view the ray. So if we go to Google, let's Google search how to view a raycast. So see 2D raycast in Unity. And you'll see here that we have things called like debug.drawRay, and that's exactly what we want. So debug.drawRay draws a line from start to start plus direction in the world coordinates. You can see here that this is basically taking the forward direction. They're doing a debug.draw. They're drawing it from the transform.position and in the direction. So for us, we can use exactly this. So let's hop back into our code. And we're going to follow this exactly. So here, debug.drawArray, and remember guys, when you're looking at the scripting reference, don't focus on their example. Honestly, just focus on the implementation details, which is debug.drawArray. From there, we can use our tooltip to explain what the rest of the information is. So if we go back into Unity here, and right after we raycast, let's actually draw what we're raycasting. So we're going to say debug.drawArray, and you'll see here that it's looking for a vector3 start. Where is the raycast starting? Well, we said it starts at transform.position right here. So we're going to say transform.position, and the vector3 direction is going to be vector2.down. And then we can give it a color. So let's go ahead and say color.green. Let's go ahead and save this. And you'll notice as well that we are using only a distance of 1, which is equivalent to using vector2.down. But say we were using a distance of 5, we would have to then use one of the other tooltip options that were provided here. You can see here that we have things like vector3 direction, and we could simply modify that. So we would say vector2.down, and we would just say times whatever our distance is. So if we were casting 5 units, we would say .down times 5. But because vector2.down is just a 1 unit vector, we don't need to do that at all. this will be accurate. Let's save this, hop back into Unity, and you're going to see here in the scene view that our raycast is going to be drawn and we can actually see what it's hitting. And there you go. We have a line coming from the center of our player all the way down. So it's hitting our player and it's clearly hitting the floor. But what's happening here is it's hitting our player first and returning that information. So what we need to do is we need to tell this raycast to basically ignore our player. So to do that, what we're going to do is we're going to create basically a layer for it to ignore. Or more so, we're actually going to create a layer for it to detect. So we only want this raycast to return information if it hits the ground layer. That way, what that's going to allow us to do is, one, it's not going to hit our player, but two, it's not going to hit enemies as well. So for instance, if we were to jump on an enemy, it won't register as you're grounded, because that's not true. You're not grounded when you jump on an enemy. You're only grounded when you're on the actual floor. So what we're going to do is if we go into the grid here and we find our floor, you'll see here that it highlights every floor walkable surface, right? Well, what we're going to do is that's what we want to detect. So to do this, we're going to create a layer. So if you drop down here, you'll see here that it has a tag of ground and a layer of nothing. Let's go ahead and create a new layer by going to add layer. Make sure you stop playing Unity. And on user layer 8, we're going to add a ground layer. So just type in ground there. And this is going to be a layer that our raycast is going to be detecting. So now what we can do is we can now tell our raycast to detect this layer and this layer only. So it's layer 8. So to do that, we can open up our script, and what we can do here is we can say hitinfo equals physics2d.raycast, our transform.position, vector2.down, the distance is 1, and if we actually hit another comma, you'll see here that we have a few more options. And one of those options is 4 of 7, which says int layer mask. So what we want to place in there is an 8, but I can't simply type 8 like this. That's not how that works. A layer mask is a 32-bit integer array, and in order to modify that or to place basically a 1 there, you can basically think of as a layer mask as a bunch of zeros. We want to place a 1 on layer 8. So to do that, we have to use what's called the bit shift operator. So we're going to say 1 bit shift, which is 2 less than signs. So 1 bit shift, and then we're going to be saying find layer 8, and that's what we want to target. By saving this, you'll now see that our raycast is going to ignore our player, and it's going to only register on the ground layer. If we run this, you'll see here that it's hitting the floor. And there you go. And now when we jump, you can see here that our grid, if we click on our player here, grounded is true. I jump up, grounded is still true, which is another issue that we're going to look at, but now our floor is being detected, and if I double jump and actually get off it, you can see here that grounded is false. As soon as I hit the floor, it becomes true. So that part is working. Now, I understand that for most, this layer issue and layer mask and what I did with this bit shift could be very confusing. Another option that you can use if you don't like the bit shift operator is you can actually just use a layer mask. You can create a variable here called private layer mask, and we'll say underscore ground layer, and we're going to set it to a serialized field so that we can see it in the inspector. And what you can do now is if you go to the inspector on the player, go ahead and stop playing. Once it finishes compiling, you'll see here that now we have a drop-down layer. And what you can do is you can select the ground layer. And to actually make use of this variable, we're going to simply come over here, and instead of doing 1 bit shift 8, we're going to swap it in and say underscore ground layer dot value, and that's going to grab whatever the selected value is. So again, nothing to be afraid of when it comes to the bit shift operator. Basically, again, a layer mask is a 32 integer array from 0 to 31. It's a list of zeros, and we want to place a 1 on the 8th layer, and that way it's like a flag system. So you can do this way, or you can just keep it as 1 bit shift 8, whichever one you feel is more comfortable. There's no performance decrease or value in using either one. So we'll go ahead and save this, and let's take a look at the other issue we had here. And that's the fact that in order for our grounded state to become false, we have to double jump. So now why is that? Well, that's because as soon as I jump in the same frame, our raycast is actually still hitting the floor. So it's never registering that we left. So a quick fix for this might be to just shorten our ray length. So let's give that a shot. Let's go ahead and inside our vector2.down here, we're going to say direction vector2.down, and let's multiply that by 0.5f. That's going to be a distance of 0.5. Likewise, we're going to do the same thing right here. We're going to cast a distance of 0.5f. And now we'll be able to draw what it is we're casting. Let's go ahead and run this. And now we have a shorter ray. We're hitting the floor, and if I jump, you can see here grounded is now false. So we may have actually cut it too short, but if we set it to true, we can jump. So let's go ahead and increase it a tad bit more. So perhaps 0.6. Let's save that. Let's go ahead and run it again. And you can see here it's touching. It's grounded as true. If I jump, it's still saying it's true because in that same frame, it's happening so quickly, 60 frames per second, that it's not letting us jump. So a workaround to this is going to be setting a cooldown timer. Basically, we're going to say, hey, grounded is now equal to false. Let's wait, like breathe. Let the program breathe and not do another raycast detection until we've given the program at least, a half a second or so. So we'll go ahead and create that in the next video.